Hello everyone and welcome to today's video session. I'm Randeep Singh and today I'll teach you about parallax method. So this method is basically used to measure large distances which we cannot normally measure by any instrument, such as the distance of a planet or a star from the earth, which we cannot measure directly by any instrument. So in that case we'll use parallax method. So firstly, what does parallax means? To understand the meaning of parallax, we will perform an activity. So students, hold a pen in your hand and stretch your arm. Now look at the tip of the pen through your left eye, keeping your right eye closed, and then look at the tip of the pen through your right eye, keeping your left eye closed. Remember students, you will have to keep the pen at the same position in both the cases. You will notice that the position of the tip of the pen seems to change. So that's basically called a parallax. There will be a change in the position of the tip of the pen when you look the tip of the pen firstly with your left eye and then with your right eye, keeping your left eye closed. So this is called parallax. Now the distance between 2 points of observation is called the basis. So basis is basically the distance between 2 points of observation, and in the previous activity basis is the distance between your both the eyes. Understand? Now we will use this method to measure the distance d of a faraway planet S. We will use to measure the distance of a planet S which is very far away from Earth. So firstly we will draw a diagram. So this is the planet S whose distance from Earth we have to calculate, and these A and B are two observation points on the Earth and distance AB, that is the distance between two observation points, is called the basis, and we'll suppose that it is equal to B, and we will suppose this distance, that is AS, is equal to D, and similarly BS will also be equal to D because D is very large as compared to B. That's why we approximately take AS and BS equal to D. Now the angle ASB is equal to theta. That angle is equal to theta. It is called the parallax angle. So students, as we know that the planet is very far away from Earth, so this distance would be very large as compared to B. So D will be very large as compared to B, and B by D will be very small as D is very large. So that's why this ratio will be very small. So as we know that angle theta is equal to arc upon radius, and in that case radius is the d, that is the distance of the planet from the Earth, and we can approximately take the length of the arc equal to b because this distance is very large as compared to this arc. So that's why we can approximately keep length of arc is equal to b. So in that way angle theta will be equal to v upon d, and from first equation b by d is very small, and similarly angle theta will be very small because b by d is very small. So d will be radius and b length b of AB is equal to arc of length b of a circle with center S. Now d is equal to AS is equal to BX, that is distance of planet from the Earth, which we have to find, and angle b is theta is equal to b by d, and from this expression d would be equal to p upon theta. So this is the very important relation. Look at that equation. In that equation we can easily calculate b, which is the distance between two observation points. We can measure b because we are observing the planet as on Earth, and so we can easily calculate b. And we can also easily calculate angle theta because when we observe from point A, we can calculate that angle, and similarly when we'll observe the planet as from that point B, we can easily calculate angle B. So as we know that the sum of interior angles of a triangle is equal to 180 degree, and knowing the values of angle A and B, we can easily calculate an angle theta. So in that way, knowing the values of B and theta, we can calculate D, that is the distance of the planet from the Earth. So in that way, we will use parallax method to approximate the large distances, that is of a planet or star from Earth, which we normally cannot measure by any instrument. So students, that's all for today. I hope all of you have understood it well. Thanks. Have a nice day.